Most people think machine learning is magic. It is not. Machine learning is an engineering discipline. It has inputs, assumptions, failure modes, and trade-offs, exactly like every other engineering discipline. The hype around it is real. The results are real. But the gap between a demo and a production system is where most projects die. This series is about closing that gap. Most people encounter machine learning through headlines and product demos. A chatbot that sounds human, a model that beats a grandmaster, a system that detects cancer from an image. Those results are genuine, but they are the output of enormous effort, careful data work, rigorous evaluation, and a lot of decisions that never make it into the press release. This series goes deeper. Real code, real decisions, real trade-offs. Not theory for its own sake, applied practice, the kind that holds up under production conditions. So, what is applied machine learning exactly? It is not about memorizing algorithms. It is not about knowing every mathematical detail of how gradient descent works. Applied machine learning is about knowing when to use a given tool, how to evaluate whether it is actually working, and, critically, when to walk away from an approach that is not going to deliver. That last part is underrated. The practitioner who knows when to stop is more valuable than the one who keeps tuning a model that was never going to generalize. Judgment. That is what this series ultimately emphasizes. Every machine learning project moves through the same arc, regardless of domain or complexity. It starts with problem framing, translating a business or research question into something a model can actually address. Then comes data, acquiring it, understanding it, cleaning it. Then modeling, selecting and fitting an algorithm to that data. Then evaluation, measuring whether the model does what you need it to do, and whether those results will hold on data it has never seen. Finally, deployment, integrating the model into a real system where it will encounter the messiness of the real world. Each stage has its own failure modes. Each stage has decisions that compound downstream. We follow that arc across this entire series. Each video corresponds to a distinct stage in the machine learning lifecycle, from data preparation and modeling to evaluation and deployment. Before we go further, let us be direct about what machine learning is not. It is not magic. There is no model that produces reliable insight from bad data, vague problem framing, or unrealistic expectations. It is not a replacement for domain expertise. A model trained on financial data by someone who does not understand finance is a liability, not an asset. And it is not always the right tool. Sometimes a well-structured rule, a lookup table, or a simple regression is the correct answer. Reaching for a neural network when a linear model would do is not sophistication. It is complexity for its own sake. Getting that framing right from the start, that alone saves projects. The best applied ML practitioners share a consistent set of traits. They are part engineer. They build systems that are reproducible, version-controlled, and maintainable. Part scientist. They form hypotheses, run experiments, and let results change their thinking. And part skeptic. They do not trust a metric until they have interrogated it. They do not trust a result until they have checked whether it survives a reasonable challenge. That combination of rigor and skepticism is what separates practitioners who produce reliable work from those who produce impressive-looking demos. This series is built around developing that mindset, not just the mechanics of the methods. Everything covered in this video is grounded in Chapter 1 of my book, Applied Machine Learning: Concepts, Tools, and Case Studies. That chapter goes deeper than any single video can. The full lifecycle breakdown, the practitioner mindset, and the reasoning behind every decision. If this is the way you want to learn, the link to my book is in the description. Worth a look. Over the next 11 videos, we move through the full applied ML lifecycle together. Data acquisition and cleaning. Feature engineering. Classical models, linear, tree-based, ensemble. Evaluation and validation. Case studies on structured and unstructured data. deep learning, NLP, and computer vision. And finally, generative AI and ethics. Each video stands alone. You can watch them in any order and take something useful away. But they are also designed to build on each other. So if you follow the series front to back, you get a complete, coherent picture of how applied ML actually works in practice. If this landed for you, the next video is where we go straight into data. Because here is the thing. Data is the model. The algorithm is downstream of everything that happens before it reaches training. That is where projects are won or lost. One more note before you go. This series uses AI-generated voiceover. Severe tinnitus, hearing loss, and central auditory processing disorder make traditional recording impractical. These tools made the series possible in a way it otherwise would not have been, which is, in itself, a demonstration of what disciplined, purposeful use of AI can enable. That argument runs through all 12 videos. This is what it looks like in practice. See you in the next video.